This video will look at a large sample, one-tailed example. All right, example 3. An interest group would like to establish that the average salary for a class of employees is greater than $32,500. A random sample of 100 employees has a mean salary of $33,422. The standard deviation of the salaries is 4,415. Test the claim at 0.05 level of significance. All right, so the first thing we want to do is we want to lay out the hypotheses. Our null hypothesis, mu equals 32.5. In the Blumen's standard, you always show the equals in your null hypothesis. The alternative or research hypothesis, in this case, we're looking for greater than 32.5. So our alternative is mu is greater than 32,500. Okay, so step 1 is complete. Step 2 and 3, we need to find critical values in a test statistic. First thing we have to do is decide which test. First thing we look at, we only know the standard deviation of the sample, so we don't qualify for the z-test on that. However, we have a sample of 100, so we do qualify for the z-test on that. So z-test, one-tailed, alpha equals 0.05. You can either work your way through the z table and figure out that z equals 1.65 will give you the closest to 95%, or in Blumen, go to the t-distribution table, go all the way to the bottom for the z infinity row, look for the one-tailed alpha equals 0.05, and you'll see 1.645. Now with the one-tailed, you need to figure out what sign it is. When you have a greater than, you're looking for basically the right side of the distribution, so your critical value is positive. Now, your test statistic. We've seen the z formula before, x over bar minus mu, sigma over the square root of n. Plug in our numbers, the 33,422 from the sample mean, 32.5 for the population mean, 44.15 for the standard deviation, and 100 for the sample size. I did the subtraction and the square root, both in this step. Did the division in the denominator, did the division overall. My final test statistic is 2.088. Now, in this case, we just have to look, is our test statistic out to the right farther than what our critical value was? 2.088 is to the right in the tail of beyond 1.65. So we reject the null. By rejecting it, we decide that the mean probably really is greater than 32,500. And I used the more proper phrasing here. There is sufficient sample evidence to support the claim that the average salary is greater than 32,500 at the alpha equals 0.05 level of significance. Now, if you were looking for p-value, you would use norm.s.dist, put your test statistic 2.088 in there with true as the second parameter. That will give you 0.981601. Now, that's the probability from 2.088 to the left, because this true tells us it wants cumulative. What we need is actually the area to the right, so we have to subtract that from 1. Gives us our p-value of 0.018399, so the p-value is essentially 0.02.